Hello, my dear bachon. Welcome back to our series where we make math your absolute best friend, especially now that exams are just around the corner. So today, we're jumping right into Chapter 8, which is all about quadrilaterals. Now, I know, some of you hear the word geometry and you start to worry, right? But listen, trust me on this one. By the end of this quick session, you're going to feel like an absolute champion. This chapter is super simple and it's a great place to score easy marks. So bilkul tension nahi lene ka.
All right, so what's our game plan for today? It's simple. We're going to meet the parallelogram family, check out their awesome superpowers, learn the mighty midpoint theorem, solve a quick question to test our skills, and then wrap it all up with a 1-minute revision. Ready? Let's do this.
Okay, first things first. Let's get to know the star of our show today, the parallelogram. And trust me, it's way simpler than it sounds. So, what in the world is a parallelogram? Well, it's a quadrilateral, which is just a fancy word for a shape with 4 sides. But here's the magic ingredient. Both pairs of its opposite sides are parallel. You know, like railway tracks that never meet. Just picture a rectangle and imagine giving it a gentle push from the top. See how it tilts? That's your parallelogram. Super simple, right? All right, now for the really cool part. Just like your favorite superhero, our parallelogram has some amazing superpowers. And these superpowers are actually its properties, the secrets that will help us crack every single question. So, superpower number 1. This is Theorem 8.1 in your textbook. It says that a diagonal, you know that line from one corner to the opposite one, well, it divides the parallelogram into 2 perfectly identical triangles. They're congruent. It's exactly like when you cut a cheese sandwich diagonally. You get 2 perfect halves that match completely. Take a look at this parallelogram. ABCD. See that diagonal AC? It splits it into 2 triangles. Now, how do we know they're identical? Well, think about it. The opposite sides are parallel, right? So we get a pair of matching alternate angles. Then they share that middle side, AC. And then we get another pair of matching alternate angles. That's the good old angle-side angle, or ASA rule, which proves these 2 triangles are perfect clones of each other. And there you have it, our first superpower in action.
Okay, moving on to superpowers 2 and 3. And these are really easy to remember. First, in a parallelogram, the opposite sides are equal in length. Not just parallel, but also equal. And second, the opposite angles are also equal. Simple as that. So, what's the big takeaway? Opposite sides are equal, opposite angles are equal. Got it? Perfect.
And for our last big superpower, let's talk about the diagonals again. What happens when you draw both of them? Well, they cross each other right in the middle. They cut each other into 2 equal halves. The fancy math word for this is bisect. So just remember this phrase, the diagonals of a parallelogram bisect each other. Look here. The diagonals AC and BD meet at that center point, O. This means that the little piece OA is exactly the same length as OC. And likewise, OB is exactly the same as OD. They've been chopped perfectly in half. Now, this is a massive clue in so many exam questions. If they tell you the length of the whole diagonal, you instantly know the length of half of it. It's like a secret key for solving problems. Okay, listen up. This is a major pro tip for your exams. It works the other way around too. This is what we call the converse of the theorem. So if you're given some random 4-sided shape, and you can prove that its opposite sides are equal, or that its opposite angles are equal, or that its diagonals cut each other in half, then bam, you can declare with full confidence that it has to be a parallelogram. It's a great tool for proofs. All right, let's change gears for just a second. We're going to take a small detour from parallelograms and look at triangles because I want to show you a really powerful theorem. I like to call it the mighty midpoint theorem. So what is this magic trick, you ask? It's Theorem 8.8, and it is just brilliant. Listen to this. You take any triangle, find the middle point of any 2 sides, and then you just draw a line to connect them. That new line you just drew, it's automatically parallel to the 3rd side of the triangle. But wait, there's more. It's also exactly half the length of that 3rd side. How cool is that? You get 2 amazing results from one simple action. Let's actually see this happen. Here's our triangle ABC. We find point E right in the middle of side AB. Then we find point F in the middle of side AC. Now watch. As soon as we connect E and F, poof, magic. Instantly that line EF becomes parallel to the bottom side BC. And at the same time, the length of EF becomes exactly half the length of BC. Seriously, remember this visual. This theorem is a total game changer, a massive shortcut that will save you so much time in the exam. Okay, bachcho, all this theory is fantastic, but we all know that the marks are in the questions, right? So you think you've mastered these superpowers? Let's put them to the test with a real exam-style question. Are you ready? Let's go. All right, let's do this. This is all about applying what we know to get those full marks, so pay close attention, okay? Okay, here's our question for today. It's actually based on example 3 from your textbook, so it's a really good one. Let's look at the pieces. We have an isosceles triangle ABC, which means side AB is equal to side AC. Then there's this line AD that's cutting the outside angle PAC in half. And finally, we're told that the line CD is parallel to AB. So, what's our mission? We have to prove that this whole shape, ABCD, is a parallelogram. So, how do we solve this puzzle? Let's go step by step. First, we use what we know about isosceles triangles and exterior angles to show that angle DAC is equal to angle BCA. Now, step 2, look closely at those two angles. See how they make a Z shape? That's our clue. That means they are alternate interior angles. And if alternate angles are equal, then the lines AD and BC have to be parallel. Boom, we've got one pair of parallel sides. Step 3 is the easy part. The question already gave us the answer. It told us that CD is parallel to AB. That's our second pair. And finally, step 4. Since we have two pairs of opposite parallel sides, what does that mean? It means ABCD is a parallelogram. See? Easy peasy. Phew, we've covered so much ground, so let's lock it all in with a super fast 1-minute revision. Think of this as your ultimate cheat sheet for the exam. Okay, butcho, get your phones ready. You need to take a screenshot of this slide right now. This table has everything you need. Look, they're all part of the parallelogram family, so they all have the basic properties, opposite sides parallel and equal, and diagonals bisecting each other. But then come the special powers. A rectangle adds 90-degree angles and equal diagonals. A rhombus makes its diagonals perpendicular. And the square? Well, the square is the superstar. It has all the properties. This table is absolute gold, so make sure you save it. And just like that, you've revised the whole chapter. See? I told you it was simple. Please remember, you are smart, you've put in the work, and you are totally brilliant. Walk into that exam hall with your head held high, full of confidence, and just ace it. You've totally got this. Hey, if this helped you out, do me a small favor, hit that like button, subscribe so you don't miss the next one, and please share it with any of your friends who are struggling with this chapter. And don't forget to tell me in the comments what chapter you want me to break down next. All the very, very best for your exams. Bye for now.